Hi, it's time for another math easy. So we're going to discuss antiderivatives, basically do an introduction to it, and basically this is, these are just integrals, but this is using antiderivative name just until I get into integrals in my later videos. I'll explain why later. But basically an antiderivative is, well, let's just look at the definition here. It's just a function f is called the antiderivative of the small case f on interval I if the derivative of this function here, or the antiderivative, is equal to the function here for all x in this interval here. So basically what this is saying is, let's say with an example, let's say if you had f of x is equal to x squared here, then if we had a function f, if we take a derivative of that function and it's equal to this one here, well, we just think about our power rule here. So if we had a function, let's say like f of x is equal to x cubed over 3 here, then the derivative of this f prime of x is this one just equals to 3x squared over 3 equals x squared, and this equals to f of x here, and this is where we get this f prime of x equals x here, f of x. So these equal each other, so then this is the antiderivative here. But what we also have to recall is that in this case here, if we had a function, let's say g of x is equal to, well, x3 divided by 3 here, plus let's say 100 here, or a constant here, then the derivative of this one is just going to be equal to, well, 3x squared over 3 plus 0 here, that's the derivative of a constant 0, then we just get x squared, and this also equals f of x here. So we have this function is equal to f of x and that as well. And I showed in my earlier video actually that if you had two functions that are the same derivative, in this case f prime of x equals to g prime of x, using part of the mean value theorem here, the difference of these two functions is just separated by a constant here. Or if you write this down here, this would just be f of x minus g of x. This one just equals to a c equals constant here, and you can see this visually by basically if you just graph a function of this one right here. If you have two functions that have the same derivative, this is x, this is y here. So let's say if this one's the same derivatives everywhere here, if this is f of x here, if this is the same derivative, then it has to look exactly the same if the derivative is the same everywhere. So it should look something like this, depending on whatever this constant is. So then this is this constant here. You can see more on this on my video link on mean value theorem below. But basically, so if we have this one here, if we rearrange this, we're going to get g of x is equal to f of x plus c. And if we basically put this together here, thus we have another theorem. This one is if f is the antiderivative of the lowercase f on interval I, this is basically whatever interval you're looking at in terms of x, then the most general antiderivative of f on I is basically f of x, or antiderivative plus a random constant here, just an arbitrary one here. So if we look back at that x squared here, so if we have f of x is equal to x squared, then we get basically a family of antiderivatives, and that's just going to be f of x equals to x3 over 3 plus a constant. And this constant, for example, you could go x3 plus 3 minus 1 plus 1 or 0 or whatnot. And if you were to graph this, basically this little family of curves here, we'll just zoom in this one. I have x to the power of 3 divided by 3 and x to the power of 3 divided by 3 plus 1. This one is a negative 1 constant, this is plus 2 constant. And if you zoom in here, you get something like this one here. Let's just fix this one here. So this is the original one. This blue one is just without a constant. This one's a plus 1, so all you do is shift it up once, and this is a minus 1 here, you shift it down here. So we have this family of curves, and these are all antiderivatives of x squared here. Well, that's all for today. In my later videos, I'm going to basically do some examples on this, and then even further on, I'm going to get into integrals, basically formalize these antiderivatives, how to get them for several different functions here. And yeah, they basically are integrals, but we're just going to call them antiderivatives in this case, just because it's basically the opposite of the derivative here. Well, that's all for today, and hopefully you learn. You can download these notes like always in the Dropbox link below, and stay tuned for another math easy solution.